Let's look at the next question. The next question is question number 5. It says in triangle ABC, angle P is 90 degree. Let's just draw a rough diagram. So angle B is 90 degree. Next, D is the midpoint of BC. So D is the midpoint of BC. Let's mark this, which means BD and CD are equal. Let that be X. Let AB be Y and let AD be P and AC be Q. We need to prove some left hand side is equal to right hand side. Let's just write the assumptions that we've taken. Let BD is equal to CD is equal to X. Number 2, AB is equal to Y. Number 3, AD is equal to P. And number 4, AC is equal to Q. Let's see what do they want us to prove. So let's work with the left hand side first. So left hand side is AC square. Now AC square is equal to Q square. Now which can be written as Q square can be written as Y square plus 2X whole square. A reason for this, since in right triangle ABC we have AC square is equal to AB square plus BC square. So this gives us Q square is equal to Y square plus 4X square. That's our left hand side. Let's see what's the right hand side. So right hand side is AD square plus 3CD square. AD square is P square and 3CD square, which is 3X square. Now P square can be written as Y square plus X square plus 3X square. Reason, since in right triangle ABD we have AD square is equal to AB square plus BD square. What this gives us is right hand side is equal to Y square, or this is Y square plus X square, not X, Y square plus X square plus 3X square, which means Y square plus 4X square. So from 7 and 10 we get LHS is equal to RHS is equal to Y square plus 4X square. So hence proved. Done. Simple. Let's look at the same question using the other method where we use the letters instead of the variables that we've created. So let's look at the left hand side. So our left hand side is, so we will start with point 1 now again. So 1 says left hand side is AC square. So AC square is equal to AB square plus BC square. Since in a right triangle ABC using Pythagoras theorem. Now I have got AP square and BC square. I notice that CD is there, which BC can be converted into CD, and AB square is a part of the other right triangle also, which I can write as AD square and BD square also. So let's just write this. So AC square is equal to AB square would be equal to AD square minus BD square plus, instead of BC I will write 2 times BC whole square. 2 reasons, since BC is equal to 2 times DC, and the second reason is since in right triangle ABD we have AD square is equal to AB square plus BD square, which means AB square can be written as AD square minus BD square. That's exactly what I've done. So now let's look at the third step, which is AC square is equal to AD square. So we've got AC square from the left hand side, we've got AD square also. Now I need to convert this BD into CD somehow, right? But BD is equal to CD, which means minus CD square plus 2 CD whole square is 4 CD square. The only thing we've done is, since BD is equal to CD, which means we get AC square is equal to AD square minus CD square plus 4CD square is plus 3CD square. That's what they wanted us to prove. So hence proof. Now let's look at the next question. The next question that we do is question number 6. Question number 6 says, in a rectangle ABCD, prove that AC square plus BD square. Good. So let's just draw the rough diagram first. These are the two diagonals that they're talking about, AC and BD. And let's name this. So this is A, B, C, and D. Vertex angles are 90. Opposite sides are equal. So let AB be equal to CD, BX. And AD and BC are equal. Let this be Y. And the two diagonals are equal as well. Let them be equal to Z. Okay. Let's write our assumptions, not assumption, what we already know. So let AB is equal to CD is equal to X. Number 2, AD is equal to BC is equal to Y. And number 3, AC is equal to BD is equal to Z. The reason for this, in a rectangle, opposite sides are equal and diagonals are equal. So that's a property of rectangle that we know. Now let's see what do we have to prove on left hand side and right hand side. So the left hand side in this case is AC square plus BD square, which is AC is equal to Z square and BD is also equal to Z square. So my left hand side is equal to 2 times Z square. Let's see if it is a part of any right triangle. So let's look at right triangle ABC. So this is equal to 2 times X square plus Y square. Let's write the reason. In right triangle ABC, using Pythagoras theorem, we get AC square is equal to AB square plus BC square. So this gives us left hand side is equal to 2x square plus 2y square. Now let's look at the right hand side now. So the right hand side is equal to AB square, which is x square, BC square, which is y square, CD square, which is x square, and DA square, which is y square, which is equal to 2x square plus 2y square, which is equal to left hand side. So hence proof, because LHS and RHS are equal. Let's try one more question using both the methods. After that, maybe I'll use only one method to solve questions in this video. So in this question, let's try the second method. So let's start with point number. So we will in this we will not take the variables. We will have AB is equal to CD, which is given, AD is equal to BC, and AC is equal to BD. Now let's look at left hand side. So the left hand side is, we work with point number 4, AC square plus BD square. Now AC square is equal to AB square plus BC square. This I have looked at the right triangle ABC, and if I look at BD, now BD is equal to AB square plus AD square. Let's write the reason. Since in right triangle ABC, using Pythagoras theorem, I get AC square is equal to AB square plus BC square, and in a right triangle ABD, using Pythagoras theorem, I get BD square is equal to AB square plus AD square. So that's the reason why we've been able to write AC square as broken up into AB square plus BC square, and we've written BD square broken up into AB square plus AD square. So the left hand side is AC square plus BD square, and the right hand side becomes, let's see what we've already got. So they wanted AB square, I've got an AB square. They wanted BC square, I've got a BC square. They wanted an AD square, I've got an AD square. So the only thing is I need to convert AB into CD. Is there a relation between AB and CD? Yes, they are equal. So I can just replace it. So this is AB square plus BC square. I change nothing, and instead of AB square I write CD square plus AD square. Reason, since AB is equal to CD from 1. So hence proof. This is what they wanted us to prove. AC square plus BD square is equal to AB square plus BC square plus CD square plus AD square. Wonderful. Let's look at the next question. The next question that we solve is question number 7. So it says in quadrilateral ABCD, angle B and angle D are 90 degrees. So let me just draw a rough diagram. Okay, no information given about the other sides. I will just take this to be the quadrilateral A, B, C and D. These are 90 degree. We need to prove AC square. Okay, so this is, I will join AC square, AB square, BC square, CD square and DA square. Perfect. So let's look at the left hand side. The left hand side is point number 1, 2 times AC square. So 2 times AC square minus AB square. What do I have? Okay, before I get into the left hand side, let's use the Pythagoras theorem in both the right angle triangles. So let's just cancel this. Number 1, in a right triangle ABC using Pythagoras theorem, what I get is AC square is equal to AB square plus BC square. Yeah, AC square is equal to AB square plus BC square. Done. Let's look at the second right triangle that we have and apply Pythagoras theorem there as well. So in a right triangle ABC using Pythagoras theorem, what I get is AC square again is equal to AD square plus CD square. Yes, this is also fine. So this is point number 4. On the left hand side they have 2 AC square, which means let me just add these two. So add equation 2 and 4 and we get point number 5, which is AC square plus AC square. I've added the two left hand sides of the equations, and on the right hand side I get AB square plus BC square. So this is from the equation 2, and from equation 4 I get AD square plus CD square. Let's see what I've already got from the answer. So they wanted 2 AC square, which I've got. They want BC square on the right hand side. I've got CD square. I've got DA square. I've got, the only thing is AB square, which if I take it on the other side becomes negative. Done. We've already got our answer. So this is 2 AC square minus AB square is equal to BC square plus CD square plus AD square. That's what they wanted, so hence proved. I have solved this question only using one method. Let's see if we can still solve it using the other method. So let's call this X, let's call this Y, let's call this Z, let's call this P, and let's call this Q. So our left hand side now becomes, okay, so this is method 2. Let's see what we can get from here. So point number 1, we get Q square is equal to, let's left hand side, what is on left hand side? Left hand side is 2 AC square minus AB square. So this is equal to AC square is 2 times Q square minus AB square, which is Y square. Yes, this is fine. BC square is X square. Okay, and this is will be equal to 2 times Q square is Y square plus X square minus Y square. Why? Since in a right triangle ABC using Pythagoras theorem, I get Q square is equal to Y square plus X square. So that's the reason I have replaced Q square with Y square plus X square. So this gives us left hand side is equal to 2y square plus 2x square minus y square. So this becomes y square plus 2x square. Let's look at the right hand side. So right hand side is equal to bc square plus cd square plus da square. So bc square is equal to x square. Yes, cd square is equal to p square and da square is equal to z square. Let's see how will this work for us. I can replace q square. I have x square, I need one more x square and I need y square. So I need to remove p square and z square. Okay, so I can write p square plus z square is equal to q square. Right? P square plus z square is equal to q square. Reason, since in right triangle ACD, q square is equal to p square plus z square. So this now becomes x square plus y square, which is equal to 2x square plus y square, which is equal to left hand side. Done. Let's look at the next question. The next question that we do is question number 8. It says O is any point inside a rectangle ABCD. Okay, so let's draw the rectangle. O is any point inside the rectangle ABCD. A, B, C and D. We need to prove, let's say this is the point O. We need to prove OB square. Okay. So let's draw a perpendicular. Why am I drawing a perpendicular? Because since this is Pythagoras theorem, I will need a right angle triangle. So let me create the right angle triangle here. Let's this point be O. Let this be E, F, G and H. Perfect. So I have drawn GH perpendicular to CD and AB, and I have drawn EF perpendicular to AD and BC. Done. And all vertex angles are 90 degree, which means all these small figures that you see here are all rectangles. Let's just write. Number 1, draw GOH perpendicular to CD and AB. Number 2, draw EOF perpendicular to AD and BC. So what we have is all these sides are equal. What we get is therefore quadrilateral DGOE, quadrilateral GCFO, quadrilateral EAHO and quadrilateral OHDF are rectangles. Opposite angle, all vertex angles are 90 degree, which means these are rectangles. So let's take some assumptions now. Let this be CF is X. So this is also X, this is also X. If this is Y, this is Y, this is Y. If GC is Z, then OF is Z and HB is also Z. If DG is P, EO is also P, AH is P. We need to have OB square. So let me join OB first. Next we have OD. Let me join OD. Next we have OC. So let's join OC. And then we have OA. So let's join OA. So what we get is therefore CF is equal to GO is equal to DE is equal to X. Number 5, EA is equal to OH is equal to BF is equal to Y. Number 6, DG is equal to EO is equal to AH is equal to P. Number 7, GC is equal to OF is equal to BH is equal to Z. So we've introduced 4 variables. Let's see what we get. So left hand side is equal to OB square plus OD square. Now OB square is a part of the rectangle of right angle triangle OHB. So OB square is equal to OH square plus HB square. So this is OB square plus OD square will be equal to, OD is a part of the right triangle EOD. So this is OD is equal to ED square plus EO square. We'll write the reason. Since in a right triangle OHB, using Pythagoras theorem, OB square is equal to OH square plus HB square. And the second one, in a right triangle EOD, OD square is equal to ED square plus EO square. Let's just write what we get. So left hand side is equal to OH square. OH is equal to Y, so it's Y square, plus HB is equal to Z, so this is Z square. ED is equal to X, so it's X square, and EO is equal to P, so this is P square. So that's my left hand side. Now let's look at right hand side. So right hand side is equal to OC square plus OA square, which is OC square. If I look at the right triangle OFC, this is equal to OF square plus CF square. And OA, if I look at the right triangle AHO, then this is equal to OH square plus AH square. Yes, OH square plus AH square. Reason, since in a right triangle OC, we've looked at OFC. Using Pythagoras theorem, we get OC square is equal to OF square plus CF square. And in a right triangle OA, we've taken OHA. OHA, using Pythagoras theorem, we get OA square is equal to OH square plus AH square. So let's see what this gives us from the right hand side. So right hand side is equal to OF square. OF is equal to Z, so this is Z square. CF is equal to X, so that's X square, plus OH is equal to Y, so this is Y square, and AH is equal to P, so this is P square. So from 10 and 13, we get LHS is equal to RHS is equal to X square plus Y square plus Z square plus P square. Therefore, LHS is equal to RHS, hence proved. So this I've used solved using the algebra method. You can solve it using the other method as well. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.